For this example, the function given in the factor form, 3x squared multiplied by x minus 4. So actually it's very easy to get the x-intercept, which is we call as a roots. We just let the fx equals to 0 for the first step. We get the roots first. Okay, let the fx equals to 0. And we got it as 3x squared x minus 4 equals to 0. From here, we solve for the this equation. We got the x equals to 0, x equals to 4. Meaning that these two value, they are the roots of the graph. That is, the graph will passes through the 0, x equals to 0, and x equals to 4. Roughly, the 4 will be here. Just plot it. And we know later on, we need to sketch the graph either in this shape. Okay, the second step I will go for the shape. The shape either will be up, or down, up, down. Yeah, down, up, down. So this the shape is actually depends on the value of the a. If the value of the a, we know our cubic function, the general form is ax cubed plus bx squared plus cx plus d. So the a value here, it will determine the shape of the graph, either is up, or down, up, down. From here, okay, for the first shape, up, down, up, we always have the value of a greater than 0. If the a is a negative, which is less than 0, then we have the second shape. So for the first shape, I got the up, down, up. Okay, so up, down, up, which the graph passes through these 2 points. There are 2 cases. So here I'm going to show you the 2 cases, how it happened. We know that the graph, the a is greater than 0. We know the shape of the graph will be up, down, up, right? So there are 2 cases might happen. The first one, it might be up and then touching the 0 and then go down and then going up like this. Or it might be go through the 1, cuts through and then go down, touching the 4 and go up again. All right. So these 2 cases, we can see that the difference is in between the 0 and 4. This part, the first part and the third part, they are the same. What's the difference is only the center from the 0 to 4. Okay, for the case 1, or we say case case 1 and case 2. For the case 1, from 0 to 4, the value of y is below the x-axis, which you have a negative value of y when the x value take from 0 to 4, in between 0 and 4. For the second case, in between 0 and 4, for any x value in between 0 and 4, the value of y is positive number. So we want to know which one is happen. We can use the number in between 0 and 4 to test the value of y. For example, I take the value of 1. Okay, the 1 is in between 0 and 4, right? So I substitute the 1 into the function, put 1 into here, and now we calculate the value of the y. Okay, when x equals to 1, we got the 3 over here, and 1 minus 4, you got negative 3, you got negative 9. Meaning that when the x equals to 1, your y will be equals to negative 9. When x equals to 1, y equals to negative 9. When x equals to 1, f1 is equals to 9. Means that, okay, case A will happen. Case 1 will happen and case 2 won't happen. All right, so we will sketch this graph on the axis that I already ready here. Okay, we just sketch like this. The graph is going up, touching the 0, and go down, and go up and cut through the x equals to 4. Okay, and it's go up, go down. All right. And now we need to take care of the domain, because the question state here, the 4, where the 4 is a 0. And this is not the domain. This is just tell you that the 4 is a 0. All right. So 4 is a 0, meaning that the 4 is, when you substitute the 4 into the fx, you will get y equals to 0, just like that. So the graph, meaning that the function did not restrict any the domain. Okay, they do not have any restriction on the domain. We just determine the domain and the range as usual. Thus, the domain and the range will be from negative infinity to positive infinity, because the domain doesn't have any special condition. So our domain and range still will be from negative infinity to infinity for any cubic function. For this function is a simple, actually want to sketch this graph is very simple. We firstly get the roots first. Okay, we get the roots, we let the f(x) equals to 0, meaning that we are getting the x-intercept. Let the f(x) equals to 0, meaning that these three factors, multiplication of these three linear factors equals to 0. We can easily get the roots, that is x equals to 1, x equals to 3, and x equals to negative 5. This means that our graph will passes through this x-axis at this point. Now we can just sketch the point x equals to 1 over here. 3 will be here. So we just plot the point on our axis. And it also passes through the x equals to negative 5. So negative 1, negative 2, negative 3, negative 4, and negative 5. So plot the point, and we know the graph will passes through these 3 points. Secondly, we are going to know the shape of the graph. So to determine the shape of the graph, we will look at the sign of the value of a, when you expand the function, you can see that the coefficient of the x cube has to be 1. So when the a is a positive, which is equals to 1, then you have the shape like this: up, down, up, up, down, up. So the graph will be in this form, going up through the negative 5, and then at some point it go down, okay, reaching the maximum point, a local maximum, and then it go down and then go up again. So at these two endpoints, you can just put arrowhead to show the graph is going up and going down indefinitely. Okay, so this is the cubic function, and again the function did not doesn't have any restriction on the domain. So the domain again will be from negative infinity to positive infinity, the same as the range. So this point is actually quite important. Y-intercept. You can get the y-intercept by putting the 0 into your x. Okay, then calculate what is the value. This is actually 15. Okay, so just label as a 15. When you multiply negative 1, multiply by negative 3, multiply by 5, you get 15. So this point is actually 15. Similar to the previous example, this is the similar function, a similar function to the previous example. We just get the root first. Okay, to get the roots, we will let the f(x) equals to 0, which means that x plus 1, 2x minus 5, and 6 minus x equals to 0. All right. So letting the factor equals to 0, you will get x equals to negative 1, x equals to 5 over 2, and lastly x equals to 6. Now you can just plot this value on the x-axis. That is, x will passes through the negative 1. So plot here. And 5 over 2 is 2.5, roughly 2.5. This is 3, so 2.5 roughly will be here. This is your 5 over 2. Just plot this point. And 6. 1, 2, 3, 4, 5, 6. So plot this point. And the graph either will go up, or down, down. We need to know the shape of the graph. All right, the shape of the graph, we have to slightly expand. You don't have to expand it out. You just can expand in your mind. X multiplied by 2x multiplied by negative x, you got negative 2x cubed. So negative 2x cubed, meaning that the x equals, the a is a negative 2, okay, which is less than 0, meaning that the shape will be down, up, down. Okay, good. Okay, going down first and then up and then going down. So the shape will be going down and passes through the negative 1, passes through the y-axis, and then reaching the local minimum, it will go up again, passing through the 5/2, and until reaching the maximum, local maximum point, then go down again, passing through the 6. Okay, again, the function doesn't have any restriction on the domain. We just put arrowhead to show that the graph is going to infinity and negative infinity. Okay, so this point is again your y-intercept. To get the y-intercept, you can just put your x equals to 0. Sorry, this one to be 0. So you will have a negative 30 over here. When you substitute 0 into the x, you will have a negative 30 for your y-intercept. This is the graph of y equals to fx. Just label it. So the domain and the range still will be the same because there is no any special condition on the domain, meaning that the domain still will be from negative infinity to positive infinity and the same as the range of function.